In this video, we're going to take a deeper look at how numbers or quantitative representation of motion come into play when we're looking at position versus time graphs, velocity versus time graphs, and motion maps. So as you can see, we have a position versus time graph here. And there are three different sections on our position versus time graph. So the first thing I'm going to do is label my three sections. So I have 1, 2, and 3. And so as I look at these, I'm going to identify which type of motion happens in each section. So I'm going to write a written description for 1, then for 2, then for 3. So if I look at 1, I see that the object has a constant positive velocity, and it starts at an initial position of 1. So I'm going to say constant positive velocity and for this one I can actually say what my constant positive velocity is. And the way I can do that is I can figure out what my slope would be. There's a couple ways you can do it. The easiest way to do it would be rise over run. So if you look here, I'm going up, up 2 over 1, up 2 over 1. So I'm going to have a velocity of 2 meters per second. Like I said before, we're starting at a positive velocity of, we're starting at a positive velocity of 2 meters per second, and our starting position is going to be at 1 meter, because that's where my y-intercept is. For part 2, we can see that it is a horizontal line, so I know my object is at rest at 5 meters. Finally, I'm looking at section 3. I know it's a constant negative velocity because it's going down. And I'm going to look and see it goes down 1 over 1. So I'm going to say my velocity is negative 1 meter per second. And that's what I'm going to write. Now I can look at how to draw my motion map and my velocity versus time graph, since I have a better idea of what types of motion I have. So based on my written description, I can see that I have a constant velocity of 2 meters per second starting at 1 meter. So I'm going to look here. This is for 2 seconds, so I'm just going to draw a dashed line here for my first section. And I know that my velocity is 2. So I'm going to put a horizontal line on the positive side of the axis at 2 meters per second. Remember, my starting position is not shown on my velocity versus time graph. For part 2, that's also for 2 seconds. So I'm going to mark that in line with the 4 seconds, since it's from 2 to 4 seconds. My object's at rest, so it's going to be on the horizontal time axis. Finally, I have my object in section 3 for 1 second, going at a velocity, a constant negative velocity of negative 1. So I have a negative 1 here, so I'm going to put a horizontal line at negative 1 on my velocity versus time graph. So it's very similar to what we're doing qualitatively, except now I have 2 numbers that I'm going to put on my velocity time graph and with my motion map. So let's now look at my motion map. For my first one, I have 2 seconds, so that means I am going to have 2 arrows because each arrow represents 1 second. I'm going to start my object at 1 meter because that's where my starting position is. And since my velocity is 2 meters per second, I'm going to have my arrow go over 2 meters instead of just 1. A way you can think about this is this would be 1, this would be 2, this would be 3, this would be 4, this would be 5. And so that's what we're looking at here. 1, 2, 3, 4, 5, the meters that the object has gone. So I'm going to go for 2 seconds. And I ended at 5 meters, which makes sense because that's where I ended on my position time graph. Then I see that I'm going to be at rest for from 2 to 4 seconds, so that's 2 seconds, which means I'm going to have 2 dots. And then finally at 4 seconds, I'm going to have an arrow going in the opposite direction. And since it's -1, I'm only going to go over 1 box. So that would be my motion map. Now make sure for your motion maps, this may be something that you forgot to do in your worksheet 1, but you always want it to be going in a cycle. You don't want these dots here or the arrows to be on top of the other ones. So you can see I spread this out into that entire section. So just make sure you're leaving enough space so all of the dots and arrows are in the appropriate locations. We're going to do one more example, and this example is going to be from a motion map. We are going to make a position time graph and a velocity time graph and our written description. So the first thing I'm going to do, again, is going to write with my written description because that seems to be the easiest thing for us. And so I'm going to look at this first section, the first line that goes across, and I'm going to look at the second line as number 2, and then the dots as number 3, and this bottom line as number 4. So for number 1, I see I'm moving back towards 0, so I have a constant negative velocity. And I see that it's going, each second it's going 2. So that means that my constant velocity is going to be -2 meters per second because it's going in the negative direction, going back towards 0, and it's going 2 spaces every 1 second, or every 1 arrow. I also want to include that it's starting at a position of, it would be 5, 6, 7, 8, so it's starting at 8 meters. Part 2, if I look here, my object is now going at a constant positive velocity, and that's a constant positive velocity, and if we look here, it's going up 1 every second, so that's 1 meter per second. Then section 3, we can see for 1, 2, 3 seconds we are going at rest. And that would be at 6 meters. And then finally, we're going at a constant negative velocity again. And if we look here, it's 1 box every second. So it's constant negative velocity of -1 meter per second. So now that we know kind of what's going on, I'm going to draw my position versus time graph, and then finally my velocity versus time graph. And so for my position versus time graph, I'm going to split it up into the time intervals that I have and the position intervals. So I know that I have a total of 8 here, position, so I'm going to mark off 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be my 8 at the top. I'm going to mark a couple in here so I can see a little bit better where my positions are at. Then I'm going to mark for my seconds, and I have a total of 10 seconds. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm going to use a different color here so you guys can see a little bit better what's happening. So I'm going to go from 0 to 2 seconds. So from 0 to 2 seconds, okay, my starting point is 8 meters. So my starting point is going to be up here at 8. My velocity is negative 2 meters per second. So that means I'm going to go down 2 over 1, down 2 over 1. Now this is not as accurate as if I was writing on the board, but as you can see, my line would be going down like this. Then from 2 to 4 seconds, in this section here, I'm going a positive 1 meter per second. So I'm going to go up 1 over 1, up 1 over 1. I'm going to connect those dots. And then all the way up to 7 seconds, up to this point here, we're at rest. So that's for 3 seconds, we just have a horizontal line. Then finally, all the way up to our 10 seconds, we're going have a negative velocity of 1, so we're going to go down 1 over 1, down 1 over 1, down 1 over 1. And that would be my line there. So now I have my position versus time graph, so that should make my velocity versus time graph easier. So I'm going to draw the same dashed lines in the same positions as I drew for my position versus time, just to make it a little bit easier for me to see. And then for marking my axes, I'm looking at what my velocities are. So my velocities maximum go to 2. So I'm going to mark on my axes up to 2. So I have positive 2, positive 1, and that would be 0, negative 1, negative 2. And so I'm going to look at my different types of motion. I can either look at my position versus time graph or my written representation. And I know that at part 1, that first section, my constant negative velocity is negative 2. So I'll put a horizontal line at negative 2. In section 2, I have a constant positive velocity of 1, so I'm going to put a positive velocity of 1. In section 3, I'm at rest, so I put a horizontal line on the time axis. And then finally, in section 4, I have a constant velocity of negative 1, so I put a horizontal line at negative 1. Remember that on a velocity versus time graph, these lines don't have to connect to each other. It's okay that they don't. That's why the dashed lines kind of help us see the separation between each of them. Based on these two examples, you should be able to identify now what the slope of the position time graph represents as constant velocity and be able to calculate that. You should be able to make a motion map. You should be able to make a position time graph and a velocity versus time graph quantitatively now instead of qualitatively.